In our last video, we talked about how to calculate the variance. Now, the variance is the main tool used in statistics to measure the spread of our data. How much is our data spread out? Or if we have a low variance, that means that our data is rather closely packed together. However, there's a problem with the variance, and we're going to solve that using the standard deviation. Now, here's the problem. Remember that the variance is the average of squared deviations. Now, that might work with some units, but with other units, that just doesn't make sense. So classic example I like to give of this. Imagine you're talking finances. You're talking about the amount of money in people's bank accounts, or you're talking about salaries or something dealing with money. So you found the deviation, you found out how much a person's salary was from the mean, and then you squared it. So now that squared deviation has a unit of squared dollars. We have no idea what that would even mean, okay? Squared dollars just doesn't really make sense. So since we had to square it to get that variance, how do we reverse that effect? Well, it's quite easy. What's the opposite of a square? The square root. So we could just take the square root of everything we did. There's our variance equation. We took the deviation, we squared it, and then we took the average. Now we just take the square root of all that, and that gives us our standard deviation. Right here, this is our standard deviation for a full population. And then here on the right, this is our standard deviation just for a sample. Note the n-1, which I explained in the last video. All right, so that's the standard deviation. Okay, and this is the tool that we most often use. If you were to read a report or look at some numbers, people would often report the standard deviation. Variance is the official tool, but standard deviation is just easier to understand because of that squared unit issue. So here's the example we did before. Remember that what we did is we took each value, we found the deviation, we did that by subtracting the mean, and then we squared that deviation so that now it's all squared values. Then we took the average, but we had to divide by n-1, right? Because it's just a sample. This was the number we got in our last video. So what's the standard deviation? Take the square root of that, bam. Our standard deviation is 1.633. Sweet. That's it. Except for the question, what does it mean? How am I supposed to interpret a standard deviation? Well, here we've got the mean of 4, the variance of 2.667, and a standard deviation 1.633. Let me show you a few graphs that for this data set. So this graph here, the blue bars, that's a histogram of our data, or it's actually better put, it's a bar graph of each value in our data set. And the green line is just a normal distribution that fits an average of 4 and a standard deviation of 1.633. You see how well it fits the data. And that's great. That's what we want. We want the mean and the standard deviation to give us a distribution that fits our data. That's what we want. But that doesn't get us any closer to interpreting what it means. Okay. And really, it's going to take a couple of videos to get a better picture of the meaning. But let me do my best here. All right. This is the same figure, but this time I've highlighted the region between the mean and one standard deviation above the mean. So the width of that green region, that is one standard deviation. Okay? Now, we generally don't look at just one standard deviation to the left. We also look one standard deviation to the right, and that's what we have here. In this figure, the green region is now going from one standard deviation below the mean up to 1 standard deviation above the mean. So that's a width of 2 standard deviations, one above and one below. So really, the standard deviation is essentially a distance. It's a distance that marks or that indicates the spread of our data. And perhaps this will hit the point home a little bit better. If you change the mean of your data, then the graph is going to shift with the mean. I'll show this to you in just a second. But if the standard deviation changes, then the shape itself is going to change in the graph. A high standard deviation is going to give you a wider and flatter graph. But the low standard deviation is going to give you a narrower and taller graph. Let me illustrate what I mean here. I have just a simple normal distribution, and currently the mean is set to 0 and the standard deviation is set to 1. We call this a standard normal distribution. Standard means mean of 0, standard deviation of 1. And that comes into play when we'll talk about the z-score, which is our next video. Okay, so I said that, go back to this, if the mean changes, then the entire graph shifts with the mean. So if I decrease the mean, the graph shifts with the mean, okay? The mean is just telling us where's the middle of our data. It's not telling us anything about the shape of the graph. It's just saying where is the data located. Okay, let me center that again. There we go. Now, what happens if I increase the standard deviation? In fact, just for comparison, let me highlight this. This is the region from 1 standard deviation below the mean to 1 standard deviation above. And actually, if you look at the x-axis, these numbers indicate that. So this is 1 standard deviation above, that's 1 standard deviation below. What happens if I increase that? Well, it starts to, the graph spreads out and it flattens. But what happens, you know what, I'm sorry, this graph decided not to do it right. This is what it should look like. There we go. I apologize. I started doing that. I knew something was wrong. The whole graph flattens and spreads out. Your data is spreading out sideways. But what happens if you have a low standard deviation? Well, it goes the other way. Your data starts to collect closer and closer to the mean, and you end up with a very large amount of data very close to the mean. All right? I'm going to explain more of this after we come back from the midterm exam when we start talking about normal distributions in the central limit theorem. That's all in the future. We'll see more about this graph and what I was just talking about then. But for now, what is the standard deviation? It is the square root of the variance so that we can fix the units. And what does it represent? It's essentially a distance that measures how far out your data is spread. And when we get to the empirical rule, which is 2 videos from now, that will make a little more sense as well. And that plays a key role into this.